Hi girls, this video is going through how to find where functions meet and how to analyze how many points of intersection there are. So here are some diagrams that show a parabola intersecting with a straight line. So in the first diagram, you can have it cutting, the straight line cutting the parabola twice. So where here and here are the points of intersection. Or you can just have one point of intersection, which is when it just touches, the line just touches the parabola. This is also called a tangent. So this means the line is a tangent to the parabola if it just touches it. So if you see the word tangent in the question, like show this line is a tangent to this parabola, it means it'll only touch it once. And then the last possibility is if they just miss each other completely. So in other words, the parabola and the the line, don't touch each other at all. Therefore, there are 0 points of intersection. Now we can find where the graphs meet by solving the two equations simultaneously. So we'll do that here. It says, find the coordinates of the point of intersection of the graphs with equations y equals x squared minus x minus 18, so that must be a parabola, and y equals x minus 3 without technology. So I want to just solve them simultaneously, and you need to be able to do this without a calculator as well as with a calculator. So if it was a paper 2 and you were allowed to use technology, you could always just graph both functions and find the points of intersection on your calculator. But at the moment, we're going to pretend it's a paper 1 where we can't use technology. So here's my two functions. I like to write them out. And now I like to label them. This is equation 1, this is equation 2. Okay, so I think the easiest thing is to well, either way you could do it because they both have y as the subject. So I'm going to sub 1 into 2. So I'm going to get all of this from 1, which equals y, and put it into this y. That's what that means. So now my equations become x squared minus x minus 18 equals x minus 3. Now let's move the x minus 3 onto the other side. So in other words, we're minusing x from both sides, which becomes x squared minus 2x minus 18. I haven't moved the negative 3 yet, so that's still on this side. And then I'm going to plus 3 to both sides. And they cancel, and just like before, these cancelled. And I get x squared minus 2x minus 15. Be careful there. It's easy for people to think that's minus 21, but in fact it's minus 15. Okay, so now you have to solve that. Feel free to use quadratic formula or PSF. I'm going to give PSF a go. So on the side here, this is how I always do PSF. I think, okay, what two numbers need to multiply to negative 15? And the same two numbers need to add up to negative 2. So what are those two numbers? That could be negative 5 and positive 3. Okay, they multiply to negative 15. And they also add up to negative 2. So they're my two numbers. So, because it's a monic quadratic, hopefully you realize you can go straight to the factorized version of x minus 5 and x plus 3. And then from those two factors, you get x equals 5 from the first one and x equals negative 3 from the second one. Now, girls, remember, you're trying to find a coordinate, the coordinates of 2 points. Or in this case, it'll be 2 points. So you also need to find the y coordinate. So I'm going to sub these values into the second equation, number 2. So I'm going to sub this into 2. And I'm going to get y equals, now it says x minus 3. So I'm just going to do 5 minus 3, which is 2. So therefore, the coordinates of this point of intersection are 5 and 2. Over here, if I sub x negative 3 into 2, I get y equals negative 3 minus 3, which is negative 6. So therefore, this coordinate is negative 3 and negative 6. So these are my 2 points of intersection. 2 points of intersection. That if we go back to the previous example, we saw that this had two solutions. 2 points of intersection. And that also meant that this quadratic here had two solutions. So it's important to understand that the number of points of intersection correspond with the number of solutions the quadratic that you're going to get has. Now, if we move on, question 2. Here, this is interesting. We've got an equation of a line. You know it's a line because the power of x is 1. But there's a constant in it that we don't know the value of, which is k. And so we're probably going to have to find that. So it says y equals 2x plus k is a tangent to the parabola y equals 2x squared minus 3x plus 4. Again, I know that's a parabola because it has x squared. And now we want to find k. So we know that there is one point of intersection because it's a tangent. That's what that tells me. So it has one point of intersection. Now, let's start the way we did last time. So y equals 2x squared minus 3x plus 4 and y equals 2x plus k. Now, to find the intersection, just like we did last time, we would make that number 1 and number 2. And we'd sub 1 into the other. So we could sub 1 into 2. And we get 2x squared minus 3x plus 4 equals 2x plus k. Now we're going to move the 2x over by minusing 2x on both sides. So we get 2x squared minus 5x plus 4 equals k, because these have cancelled out. Then we're going to minus k from both sides, because remember, girls, you can't solve a quadratic until it all equals 0. Okay, so I've just got 4 minus k at the end. They both make up the constant term, because there's no x next to either of them, the 4 or the k. Now, I want to find k. Notice they haven't told me to find the point of intersection, so I don't need to try to solve this for x. I just need to use the fact that it only has one solution, or one point of intersection. So, girls, the idea is so let's write this down. Because there is only one point of intersection, this equation, so this one here, will only have one solution. Now, to hopefully help you understand. Now, what do we know about a quadratic with one solution? Hey, wait a minute, we know the discriminant is, hopefully you know, it's 0. So a discriminant is 0 when there is only one solution. So therefore, the discriminant of this whole quadratic is 0. So rather than trying to solve it, which we can't anyway because we don't have k, we can sub all the necessary values into the discriminant, make it equal to 0, and solve it for k. That's how we do this type of question. Now, what is the discriminant? Well, first of all, hopefully you notice, in this quadratic, a is 2, b is negative 5, and c is all of this constant 4 minus k. So let's put that into the discriminant. So the discriminant equals b squared, which is 25, minus 4 times a, which is 2, times c, which is 4 minus k. Notice I use brackets there to make sure I multiplied the 4 and the k. So I get 25 minus, okay, this here is 8. So 8 times 4 is 32. And 8 times negative k is negative 8k. But remember, you got this minus as well. So negative 8k is positive k. 8k, sorry. So I have, if I simplify these two, I get 8k minus 7. And all of that equals 0 because we sit over here. The discriminant equals 0. So therefore 8k equals 7. Therefore k equals 7 on 8 because you divide both sides by 8. Okay, so I want to reiterate again. Why didn't I solve these simultaneous equations like I did in the last one? Because they didn't ask me for the points of intersection. If a question asks you for the points of intersection, you have to solve the simultaneous equations. But if they just tell you to show that it only has one point of intersection or 2 points of intersection, then you can use the discriminant to show whether it's equal to 0 or positive. That's one thing you can do. In this example, they told us it only has one solution by telling us that it's a tangent, and therefore we can use the fact that the discriminant would equal 0 to find k. So it's important to know that what strategy to use. Now, girls, I know I have this this next question here, but I'd like to do another question that I had mentioned a second ago. Basically, if a question says something like, we'll call this question 4. Okay, show that the parabola y equals x squared minus 3x plus 2, and the line y equals x plus 1 intersect twice. Okay, now to do this, we could find the points of intersection, solve them simultaneously. Or we could start to solve them simultaneously, find the discriminant, and then show that it intersects twice that way by showing that the discriminant is bigger than 0. So let me show you. First of all, here are 2 equations. Okay, we call them 1 and 2. So I'm going to sub 1 into 2. And I get x squared minus 3x plus 2 equals x plus 1. Now I'm going to minus x and minus 1 from both sides to cancel these out. And I get x squared minus 4x plus 1 equals 0. So now, remember what I said before, the number of solutions this quadratic has equals the number of points of intersection these 2 functions have. Okay, so if we can show that there's 2 solutions without even solving it, we can do that. However, if that's something you don't remember, say in a test, you can always just solve the equation and show that there's 2 solutions. So basically now, by finding the discriminant, and remember, for this quadratic, a is 1, b is negative 4, and c is 1. So we get b squared minus 4 times a times c, which is 12, and that's bigger than 0. So therefore, there are 2 solutions to the quadratic equation. Therefore, the parabola and line intersect twice. Okay, so that's another type of question you could get. And so by using the discriminant, you can show that it intersects twice. Otherwise, if you don't think of that method, you can also just solve the simultaneous equations like we did in the first one. And by finding both points of intersection, you're showing that it intersects twice. Now back to our previous example. Oops. Okay. So delete that. Oh, there we go. Okay, now, it says consider the curves y equals x squared plus 5x plus 6 and y equals 2x squared plus 2x minus 4. Now, they're both parabolas because they have x squared. So it's saying solve for x, and they've just equated the two parabolas here. So let's solve it. Okay, so let's solve it. So here's my equation, x squared plus 5x plus 6 equals 2x squared plus 2x minus 4, okay? So I'm going to minus x squared. So move everything onto the right-hand side because that way the x squared term will be positive when we subtract 2x squared and take away x squared. Okay? So that becomes 5x plus 6 equals x squared plus 2x minus 4, take away 5x and take away 6. We'll do both at the same time. These cancel and we get x squared minus 7x minus 10. Oops, sorry, apologize. That's minus 3x minus 10 equals 0. Okay, so that would have a solution of x minus 5 times x plus 2. Sorry, not a solution, but a factorization of that. So x equals 5 and x equals negative 2. So they're the points of intersection of those two parabolas. That's not what A asks. It just asks you to solve the equation, but hopefully you know that they're the x values. They're the x values of the points of intersection of those two parabolas. So now, question B. For what value of x is x squared plus 5x minus 6 bigger than 2x squared plus 2x minus 4? Now, we know the values that they're equal to. That's when x equals 5 and x equals negative 2. But now we want to know when x squared plus 5x plus 6 is bigger than 2x squared plus 2x minus 4. Now, I want you to think about that for a second. Basically, what we can do is, I'm just going to show you, if we write out that inequality from B, and once again, I'm going to move everything onto that side, which will give us the same quadratic we got before, but over here, and that'll be less than 0 because all of this is moved. So in other words, I want to know when x squared minus 3x minus 10 is less than 0. That's equivalent to our original inequality. So to do that, let's do a sign diagram. So my critical values for that quadratic were found before at 5 and negative 2. So let's put those on our sign diagram, 5 and negative 2. Now, what's a number in between negative 2 and 5? Well, that 0 would be in between there, wouldn't it? So let's put 0 in here. If 0 minus 10, oh, that is negative. So this area is good. In between negative 2 and 5 is good. We wouldn't include 5 or 2 because that's when it equals 0, not when it's less than 0. Now, I can also check the outside, but I already have a feeling it won't work. So, for instance, a number over here is like 6. So 6 squared is 36, minus 6 times 3, 18, so that would be 18, minus 10 is 8. That's not less than 0, so that's not good. Similarly, this won't be good either. We won't get a number less than 0. So the values that satisfy x squared minus 3x minus 10 is less than 0 are between negative 2 and 5. So that's x is between -2 and 5. Now remember, this is just a rearrangement of the original inequality, so this also solves the original inequality. So now all of this corresponds to exercise 1E. So I strongly suggest now that you've watched this video, you should go to exercise 1E, do as many questions as you can that you have time for, do some repetition and make sure that you understand all the concepts here. The important things that you need to take away is to find the point of intersection of two graphs, you just solve them simultaneously. And to find how many points of intersections there are, you can just use the discriminant. And to find a missing coefficient, like when we found k, you can also use how many points of intersection they are and use the discriminant again. So they're like the three main strategies that you'll be using in this exercise. Okay, thank you, girls.